question 8. First up, we have a trig identity. So we want to prove the identity sine of 2x over 1 half tan squared x is equal to 2 sine x cos cubed x. So with an identity, never start with both sides. Start with one, try and play around with it, see if you can turn it into the other side. So what we're going to need to know here is sine 2x is 2 sine x cos x, and tan x is sine x over cos x. So we are going to get on the left hand side 2 sine x cos x on top, and then on the bottom 1 add sine squared over cos squared. Okay, so if we combine the terms on the bottom, we've got 2 sine x cos x on top. Now if we think of 1 as cos squared over cos squared, and sine squared over cos squared, we can then say that this is 2 sine x cos of x over cos squared and sine squared over cos squared of x. Now cos squared and sine squared is just 1, so we got 2 sine x cos x over 1 over cos squared of x. So we're dividing by a fraction, which means we flip it over and multiply by it. So this is going to give us 2 sine x cos x times cos squared of x, which does indeed give us 2 sine x cos cubed of x. Cool. Okay, then part B for 6 marks says, hence find the integral of 4 sine 4 theta over 1 add tan squared 2 theta with respect to theta. Okay, so if we take that 4 out, and then this is 4 times the integral of sine 4 theta over 1 and tan squared theta with respect to theta. So we can now compare that to what we were given up here. The x's are now 2 theta, because we got a tan squared x on the bottom, sine 2x up on the top. So we're saying that where there was an x in part A, x is now 2 theta. So we can think of 2 sine x cos cubed of x is now 2 sine of 2 theta cos cubed of 2 theta. So, the integral then, the integral of 4 sine 4 theta over 1 add tan squared 2 theta is equal to 4 times the integral of 2 sine 2 theta cos cubed of 2 theta with respect to theta. So this, actually, let's take that 2 out the front as well. So we're going to have 8 times the integral of that stuff. So at this point, hopefully we're at least thinking of either integration by parts, because we have 2 functions, or integration by substitution. Now, we could use parts, but it's going to be a complete nightmare. Neither of the functions get nicer, really, when we differentiate them, so it would take a few iterations. I think substitution would be the way to go. So let's see what happens. So let's say that u is cos of 2 theta. Then du by d theta would be minus 2 sine of 2 theta. So from that we can get that d theta is minus du over 2 sine of 2 theta. So that's going to do something really nice. So let's put our substitution in. So I is 8 times the integral of, well, sine of 2 theta times u cubed, and then we know d theta is minus du over 2 sine of 2 theta. So we can say times minus du over 2 sine of 2 theta. So let's take that minus at the front. So that's going to give us minus 8 times the integral of sine of 2 theta u cubed du all over 2 sine of 2 theta. Now we can divide that 2, so we get minus 4 on the outside of the integral, and the sine of 2 thetas cancel. So we get left with the integral of u cubed with respect to u. So, this is going to give us minus 4 lots of u to the power of 4 over 4 plus c. So, we got minus 4 times u to the 4 over 4, so that is just minus u to the power of 4, add c, undo the substitution, which was that u was cos of 2 theta, so we just get minus cos to the power of 4, 2 theta, add c. Cool.